Hi everyone, hope you're enjoying the conference so far. Let me just step up on this little stool, pretend I'm tall. So for the next 10 minutes or so, you're going to have me talking to you about building an MCP server for React component based on our learnings here at AG Grid for building an MCP server for our data grid. So just a bit of background about myself first. So my name is James Swinton Bland. I'm the DevRel lead for AG Grid. I've been here for about 2 years or so. And here at AG Grid, hopefully you would have heard of us already before, or if not, seen some of the adverts during the breaks and the interludes. But we provide a data grid library that you can see here on the screen at the moment. So the idea is that you take our library, you plop this into your React application, and you're able to take advantage of all these different features that you see here on the screen in front of you. So one of the coolest features that we have inside our data grid is the integrated charting feature that you can see now that lets you build charts directly from the data grid, much like you would in Excel. And all of this is powered by AG Charts, which is our JavaScript charting library, which also has support for React. So you can use this from within the data grid, or you can also use it externally as well as its own sort of standalone library. Anyway, we only have about 10 minutes or so let me just jump straight into the talk. If you have any questions or want to learn more about AG Grid or AG Charts, head over to our booth, and myself or my colleague would be more than happy to talk to you about it. So before we jump straight into MCPs, what they are and how they work, I kind of want to start with the problem that MCPs are designed to solve. And I'm going to call this the context problem, and I think Ken alluded to it in the AI panel earlier as context rot. So just to give you a bit more context about the context problem, here at AG Grid, we have over 360,000 different pieces of documentation and examples that are spread over 4 different frameworks and almost 90 different versions of our product. So in order for an LLM to know everything there is to know about AG Grid, it needs to consume all of this context, which is absolutely huge. And the problem is that LLMs take an average of all of their training data. So this makes a ton of sense in a lot of use cases where you kind of want a nuanced, well-researched opinion from your LLM when it's providing responses to you. But when it comes to coding or referencing documentation, that's not good enough. We want it to be black and white or true and false. We want it to be deterministic, and LLMs can struggle with that. Another way of looking at this is that LLM context is not version aware. So if I'm using a certain version of a product, the LLM doesn't know what version of documentation to refer to in order to best inform itself on how to complete that request. And then finally, I think this is something Theo alluded to in the panel as well, is LLMs don't remove context from their memory. So if we deprecate an API or change the way something works, an LLM doesn't know to stop referring to the previous way of doing things and only use this new improved way. So we're seeing this manifest itself in AG Grid. To give you an example, we moved away from legacy CSS for styling our data grid, and we incorporated a new theming API. The ironic thing is the theming API is much more suitable to LLMs. It's very structured, and it would be easier for them to use. But because we have years and years worth of content on using CSS rather than the theming API, it often falls over and defaults to using CSS. So with the latest versions of AG Grid, that can be a bit of a problem. So what is the solution? Obviously, it's Model Context Protocol. So MCP is an open source standard for connecting AI applications to external systems, and it was proposed by Anthropic. So they have a nice analogy on their website for how you should think about MCP. So in the same way that a USB-C port provides a standardized way to connect electronic devices, MCP provides a standardized way to connect AI applications to external systems, such as our documentation, for example. So let's take a closer look at how an MCP actually works. So the first thing you need to do is you start with your MCP host. So this will be your favorite LLM. It could be Claude, Cursor, Copilot, whatever it is, provided it supports MCPs. And they offer you the ability to install MCP servers within them. After they've been installed, anytime an MCP host is initialized, anytime you create a new session, they'll spin up one MCP client for every MCP server that you have installed. And these clients manage that communication with that server on a one-to-one basis, and they communicate either through standard I/O or through HTTP, depending on whether that server runs locally within the MCP host or externally on some server somewhere. So you kind of have a lot of options in terms of where you deploy your MCP server. The MCP server then, in turn, exposes 3 different features, the first of which are prompts, and then resources, and also tools as well. So we'll touch on more of on each of these in more detail in just a moment. But before we do, it's also important to note the MCP is often backed by some sort of source of truth. In our example, this will be an external database, but it could be a file system. It could be anything, really. So let's take a look at the specific features that are available within MCP, and we'll start with the simplest, which is prompts. So prompts are essentially the same thing a user would put into their LLM, but it's written by the MCP author who is meant to be the subject matter expert in this technology. So rather than the user having to write out prompts for all these common use cases, they can instead just reference the prompts that sit within the MCP, and these will give very clear instructions to the LLM on what to do and how to use it. So in our example, in our MCP server, we have a quick start prompt that lets users very quickly spin up a new data grid inside their application. And they can also pass through additional parameters to this as well, so they can kind of customize it based on their specific use case. The next feature inside MCP are resources. So in the same way that a user can reference a local file from their code base, usually by just @ing it inside the chatbot and bringing that into their prompt, you can also reference resources that exist within the MCP server itself. So in our example, we have resources for our documentation, our examples, as well as our API references. So this is an easy way that the user can bring in additional context into their LLM. And then finally, we have tools. So this is by far the most important and the most interesting piece of MCP, at least in my opinion. So tools are executable functions that an AI application can invoke to perform an action. So in our case, we have a tool that enables the LLM to search our documentation. So they simply pass through their query. They'll pass through what version of the product they're working with and what framework they're using. We'll then make an API call to our external server, which then takes this query and returns the most accurate result. And we pass that result in a condensed markdown format back to the LLM so that it can better inform itself to complete the user's request. But really, the interesting piece of this and what we skimmed over is how this fetch search API actually works and how do we actually let the LLM search our documentation. So in order to do this, we had to build something that we're calling AG Search, which is an LLM-optimized search tool that provides framework and version-specific context in a condensed markdown format. So let's take a little bit of a closer look at how AG Search actually works. The first thing we needed to do was we needed to create a whole new database that is specialized for this use case. So we took all of our documentation and examples, all 360,000 of them, and we chunked it. So we chose to chunk things based on the H2 level within our docs. So everything that sits within a H2 section became its own chunk. We took each of these chunks and we passed them through an embedding model. We use one from OpenAI, but there's lots of others available as well. And what this embedding model does is it analyzes the chunk and it takes the semantic meaning from that chunk and turns it into a vector array. So that's quite an important thing to note here, is it's not just kind of embedding this chunk into a vector array, it's figuring out what is that chunk trying to say, getting that semantic analysis from it, and then putting that into a vector array, which we then go ahead and store inside of a Postgres database, which is optimized for storing and querying these vectors. So now that we kind of have this database set up, this LLM-optimized database with all this vectorization going on, we're able to actually start calling this from our MCP server. So let's take a closer look at how that works. So the MCP server will make a tool call, in this case to search the documentation, and it will send this request through to AG Search. So it will pass through the query, the framework, and the version, as we just saw in that code example before. We then put that through the embedding model so that we can get the semantic analysis of that request and turn that into a vector array. And we also include the plain text request as well, so we can create a hybrid query statement. We then execute this query statement on the Postgres database, and we use a plugin called PG Vector for performing cosine similarity. These are a lot of big words that are potentially a little bit beyond me, but essentially what we're trying to do is find the nearest match in our database to the LLM's request. We get that vector array back from our database, pass that back through the embedding model, and then we get this condensed markdown format of additional context that we can provide to the LLM so that it can better serve the original user's request. So I have a very trimmed down demo here that kind of shows this in practice. So we spin up a new instance of Claude, and here we call the quick start prompt to create a new data grid within our application. And we say that we want to include sorting, filtering, row grouping, and editing as specific features. The MCP calls a tool to figure out what version of AG-Grid we're using, and then it uses that to make an additional call to search our documentation for the features the user wants to use. We accept that, and it goes ahead and writes our code for us, and then we have a complete AG-Grid React component inside of our React application in a matter of minutes. So I've obviously massively trimmed that down. There's a whole load of steps the AI took that I've skipped there in the interest of time. So that is a whistle-stop tour of MCP servers for React components. If you scan our QR code here, you'll be able to take a look at our docs and see it in a bit more detail. And if you want the slides from this talk, I'll be sharing them on LinkedIn after the conference. So thank you all for your time, and I hope you enjoy the rest of the afternoon.